Okay, we continue now with our discussion of the data manipulation language in SQL. And here is where we stand. So SQL, two broad parts in terms of commands. We have the data definition language, and then we have the data manipulation language. So we have a set of commands used to create the database and restructure it from time to time. And now we are looking at the commands associated with manipulating the database. And there again, we broke it down into two broad pieces. Those that change content. Those were your insert, update, delete commands, and command that does retrieve. And we made the observation that in terms of manipulating the database, the vast majority of manipulation operations involve retrieval, not making changes to the content of the database. And the SQL statement that helps us do retrievals is the select statement. Okay, and that's what we are working on. In the last class, we spent a fair amount of time on it. So just to remind ourselves, this is the broad structure of the select statement. And you can think of the select statement as consisting of a number of clauses. So you have select, from, where, group by, having, order by. And two of these clauses were absolutely essential, that at the bare minimum they must be there. So select, from, those two clauses must be there. These other ones are optional depending on what type of retrieval you want to do. Okay, and in the previous lecture, we spent a good deal of time on the select from clause. What follows the select clause? How do you specify columns? Things like aliasing columns, aliasing tables, and so forth. And then we had a good discussion of a detailed discussion of what is specified in the from clause. There you specify the tables from which the extraction is done. And in the process, we talked about joins. If you have to extract information from multiple tables, you have to connect them together. The operator for that is join. And then we had a discussion of all the four different types of joins and so forth, how the results are different depending on what type of join you do. So that's where we are at the moment. And in today's lecture, in this particular lecture, we will focus on the where clause. Okay, it has, again, a lot of nuances, complexities to it. That's what we will go through. And then in a subsequent lecture, we'll look at the remaining three. So for today's class, we are focusing on the where clause. And we'll have a discussion of what does it do, when do you need it, and what is the grammar for doing it. Okay, so to motivate the use of the where clause, let's look at a few examples using the vendor relational database that I've used from time to time in our discussions. So here is our good old vendor database, and in the previous presentation, in the previous lecture, we talked about the select from, those two parts of those two clauses of the select statement. And the examples that we said is, suppose I want the names of the customer who has placed a particular invoice, who is associated with a particular invoice. We would need to join the invoice table with the customer table and so forth. Okay, so those are the examples that we use to motivate how to structure the select clause and the from clause in in a SQL retrieval, and also different types of joins. So let's consider a different query right now. Let's say I want to know the names of all my vendors who are located in Tennessee. So this is an example of an extraction that requires selection of a few rows. Okay, so I have this one table called vendor, and from the vendor, I only want to extract a few rows. All the examples that we saw in the previous lecture, they didn't select particular rows. They were selecting all the rows from multiple tables depending on where the joins were happening and so forth. But we never tried, there was never an occasion to extract specific rows from the table. That's what we are getting into now, the examples that we are looking at now. So let's say I want the vendors, the names of vendors who are located in the state of Tennessee. The first thing that needs to happen is, from the vendor table, I need to extract the rows that correspond to Tennessee as the state. So I would extract the first vendor, the third, and here's another one, here's another one, here's another one. So total of 5 vendors from Tennessee. So I would extract those 5 rows, and then I would slice out this vendor name column. Once I extract the rows, after I extract the rows, I would slice out the name of the vendor. Okay, so this is an example of a situation where I want to get only some selected number of rows based on a condition. Remember, in this example, the condition that I specified is the vendor must be located in the state of Tennessee. Another example, suppose I want the description of products that cost more than $100. I would first need to extract the rows for which price is more than $100. So I extract rows based on a condition. I specify a condition that tells me which rows to extract. Once I extract the rows, then I can slice vertically and get the descriptions of the product. Okay. In a similar vein, you can do this selection from after a join. Okay, so let's say I want to know the description of products that are supplied by vendors from Tennessee. So just think about the statement that I made. I want the names of products that are shipped to me by vendors from Tennessee. So I would first pick out the vendors from Tennessee. Then I would connect those vendors to the product table using the vendor code. This is the foreign key that I would need a join to do that. You've already seen in the previous class how to do a join. Once I do a join, I will get a result that consists of one big table that connects the vendor information and the product information for only the vendors who are from Tennessee. And then I can slice vertically and find the description of the product. So we will see details of how these things happen mechanically, but I'm trying to give you a high-level idea of examples of queries where you want to extract certain rows from tables or from results based on conditions. All right. So this is the situation where you want to pull out specific rows based on a criterion. That's when the where clause is used, and that's what we will look at in some detail today, because the way you specify the criteria for extracting the rows, that can get fairly sophisticated. So we will gradually start from simple examples and work our way up to more complex examples of how to specify the criteria for doing the extraction. Okay. So as we just mentioned, that the absolute bare minimum in terms of the clauses that you need to have when you specify, when you write a select command in SQL to do retrieval, you must have select from. Those two are bare minimum. Why? Because the from clause tells you which tables to extract your information from. If I don't know which tables to extract information from, I'm dead in the water. That I really cannot proceed any further. And the select clause tells you which columns to pick from those tables. Okay, and you might want to pick all the columns, some of the columns, and so forth. All right. So this is the bare minimum. Now we are adding on more clauses that would be used as and when necessary, depending on the question that's being posed to the database. Okay. So this is the where clause. We're going to spend all our time today in this lecture discussing the where clause. And if you think of the examples that we just have been talking about for the last few minutes, the where clause is the clause that is used to extract specific rows based on criteria. Just like saying the state for the vendor must be Tennessee. That's a criterion. So based on that criterion, I would extract rows. Okay, so the where clause is used to specify the criterion that would be used to extract the rows. Let's just remind ourselves once about the order in which the clauses are executed. So remember, let's see, go back here. So the order in which we write the clauses when you actually issue the commands to a database management system, the select command, this is the sequence in which we write the clauses. Select, from, those two must always be there. Then depending on our needs, we may have a where clause, a group by clause, a having clause, and an order by. So this is the order in which we write the clauses. But when it comes to actually executing the clauses, this is the order in which they're done. So the first thing that the database management system does when it sees that list of clauses that you gave it, it says, where do I get the information from? Which tables do I need to get the information from? So the very first step that's executed is the from clause. So it knows, okay, I need to get my information from these tables. The next clause that's executed is the where clause. So once I know which tables to extract from, yes. So once I know which tables to get my information from, the where clause specifies the criteria that identifies which rows to pick out from those tables. Okay, and then these other clauses we will discuss gradually. We haven't discussed the group by or the having, though that will have to wait for the next lecture. But the last clause to be executed is the select. So first identify the tables from which you need to extract information. In the process, we may need to do a join. You saw in our lecture, the previous lecture, that the from clause allows you to do joins also. So the from clause tells me here are the tables from which I extract information. The where clause tells me the criteria that identify the records that have to be extracted from this set of tables. And then at the end, I select the columns. The select clause lists the columns that are to be extracted. Okay, so since we haven't discussed these two clauses yet, group by and having, we will postpone them till the next lecture. For today's lecture, just remember the sequence in which operations get done is the from clause is executed first, followed by the where clause, and followed by the select clause. The select is always done last. Okay. So for today's lecture, just think of the select statement as just having these three clauses. Select from where. The remaining two clauses, group by and having, we will introduce them in the next lecture. So they are optional in the sense that they are used as and when needed. The select and from absolutely must be there. And today we are adding to that by looking at how the where clause works. Okay. And the way to interpret the where clause is that the where clause is followed by certain criteria, conditions. And let me put the pen here. If you think of a table, now this table could be a table by itself, that is a table that already exists in the database. Sometimes that's called native tables, tables like vendor, customer, products. So this table could be a table that actually already exists in the database. This table could also be the result of a join. Remember in the last lecture we said that when you do joins, whether it's one join, two joins, three joins, the end result is always one table. Okay, so whatever the source of this table, whether it's a table that exists native in the database or it's the result of a join, for purposes of understanding how the where clause works, just think of this one table which has a bunch of rows. Every table has a bunch of rows in it. Okay, so the where clause will specify a condition, and we will see there are many variations of the condition. So a very simple condition would be state equals Tennessee. So all that the system does is it goes through row by row and it picks out those rows that meets the condition. So wherever the condition is true, the system picks out those rows and puts them in the output. Okay, so the output has the same number of columns as the table, but a fewer number of rows. It has fewer rows based on the conditions that's specified. So that's mentally how to think of the where clause. Think of a table and think of all the rows in the table. The where clause specifies some criteria, and you go to the table and pick out the rows that meet that criteria. The thing is that this criteria could be very simple, it could be very complex, depending on what is it that you're trying to, what kind of information you're trying to extract, and we'll see those variations. But that's the basic idea. From a table, pick out the rows that meet certain criteria. Okay. So this diagram shows you in pictorial form what I said in words right now. So the from, remember we said that the from clause is executed first. Let me pick up the laser pointer. Okay, so the from clause is executed first, and we know from our previous lecture that the from clause allows you to do joins as well. So you could have one table, two tables, multiple tables, and this from clause, the end result of the from clause is one table that comes out of the from clause. Either that one table is a table that already exists in the database, or it's a table that has been created as a result of joins. Okay, so depending on the type of join, the records that show up in that one table would vary. But at the end of after executing the from clause, the end result is one table. Okay, that's the end result of the from clause. Then, using this one table, the where conditions are applied. So the where clause is followed by some criteria. You specify some criteria along with the where clause, and that criteria identifies the rows from that one table that need to be pulled out. Okay, so the number of columns that are there in the result. So after the where clause is executed, the number of columns in this result is exactly the same as the number of columns in this one table. However, it will have fewer rows because you have pulled out only those rows that meet the condition. Okay, and once that is done, the last step is you select the columns from the result. Okay, so this table would have the same number of records as the output over here. So at the end of the where clause, whatever number of records that you have, those same number of records would be there in the answer here. However, the select clause only pulls out a certain number of columns. So you can think of slicing and dicing. So the where clause slices the table horizontally. Following that, the select clause slices the result vertically. So horizontal slicing followed by vertical slicing. So if you keep this sequence of actions in mind and keep this picture of slicing and dicing of a table, it should be reasonably easy to follow the grammar and the syntax of these commands once we get into the nitty-gritty. Okay? Okay, so we said that the where clause is followed by certain criteria or conditions that you specify. Okay, and the mechanics of how the where clause works we discussed just a couple of minutes ago. So the system goes row by row in the table. So you have this one table, and for the way the where clause works is the system goes through that one table row by row and evaluates this condition. So for the first row, it says, is this condition, whatever condition you have specified, is it true? If it is true, it includes the result in the output. If it's not true, if it's false, then it does not include the row in the output. So it's just how it picks out the rows from the tables. Okay. So the example that we had from the vendor table, the condition might look like vState equals Tennessee. So this is a condition expression. So this is my way of telling the system, please look for vendors whose state is Tennessee. So this is an example of a condition expression. And we'll see variations of the condition expression, but this is how the mechanics of how it works is that the system goes row by row, and for every row where the condition is satisfied, it pulls out the row into the output. If it is not satisfied, it doesn't include the record itself. Now, these condition expressions, usually they use operators. They use comparison operators, as you can see over here. The comparison operator. So the example that you saw, vState equals Tennessee. This is an example of a comparison. Okay, so condition expressions use comparison operators, and examples of comparison operators are equal to, greater than, less than, not equal to, etc. Okay, so you could have, pick up the pen. So you could have an expression that vState equals Tennessee. Okay, and you can always also combine comparison operators. So here is one comparison operator. You could have another comparison operator. Okay, and you can combine them with and, or, not. So there are different ways of combining comparison operators. So this expression could get fairly complicated. All right. For instance, I might want a list of products that whose price is more than $100 and which are drills. So I want a list of all products which are drills but which cost more than $100. So that would be an example of a situation where you have multiple comparisons that are combined using and or not different operators. Okay, so these are sort of pieces of the of how to construct the condition of this particular expression. So this expression is constructed, the condition expression is constructed in a certain way, as we will see those details as we go along. But the end result of all of that is that whatever the condition expression is, it must evaluate to true or false. And depending on the result of that evaluation, if the expression, however complex it might be, the end result of that evaluation must be either true or false. Either the expression is true or it's false for a particular row. If it evaluates to true, the row is included in the output. If it evaluates to false, the row is not included in the output. Okay, so let's continue to look at how this condition expression can be built. We'll start small and then we'll actually work our way up to more and more complex condition expressions, see how more complex condition expressions can be constructed. Okay, so here's a list of comparison operators. Now, comparison operators typically we'll start with numeric variables, right? So the comparison operators can be equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. If we are comparing two quantitative things, all right? So here are some examples. So in the where clause, we could say where column equals value. So example, where age equals 18, where city equals New York. So let's say I want to get a list of all my customers who are in New York City. Then I would have select from, etc., etc. In the where clause, I would say city equals New York. Okay. So just think about how this would be executed. This is an expression, and when you evaluate the expression, the end result can only be true or false. For instance, if I look at a particular customer, if I look at a record in the customer table, and I look at the first customer, and I look at this expression for that customer, that expression is either true or false. Either that customer is in New York or they aren't. Okay. So if the customer is in New York, I include the customer in the output. If the customer is not in New York, if the city is not New York, then I don't include the customer in the output. Okay. So this is an example of an expression that has the equal to operator for comparison purposes. Not equal to. So I could say where city is not equal to New York. You can see this expression is exclamation mark followed by equal to. Okay. Usually keyboards don't have a separate not equal to sign. A lot of mathematicians will write not equal to this way, but that symbol is typically not available on keyboard. So the not equal to is usually expressed in one of two ways, either exclamation mark followed by equal to, or less than followed by greater than. So either way, it depends on the software system that you're using, the particular database management system that you're using. But in any case, so the interpretation is fairly clear. So if the condition says city is not equal to New York, I would be picking out all my customers who don't live in New York. Okay. Similarly, greater than, less than are comparison operators. Less than or equal to, greater than or equal to are different comparison. Okay, so here let's look at the greater than or less than. I think comparison of greater than and less than, it makes intuitive sense when the values are numeric. So I could say price greater than 100 and the meaning would be very clear. Okay, so I'm trying to find, let's say, all my products that cost more than $100. All right. Now, if the variable attribute involved in the comparison is non-numeric, if it's alphanumeric, it's not immediately obvious what we mean by greater than or less than. Okay, so if we say where city is greater than New York, intuitively it doesn't make sense, because the greater than, less than, that concept we associate with quantitative things. Something is larger than something, something is smaller than something. But if the variable, in this case, you can see this attribute called city is an alphanumeric value. It's the names of cities. If the value is alphanumeric and we use the greater than operator, the way the system works is it sorts things it sorts the values in alphabetic order based on the letters, okay, and uses that for comparison. So if you have, let's say, Saratoga as a city, then Saratoga would be greater than New York because S is greater than N. So let me write that down. So let's say I have a city called Saratoga. Okay, that's another city in New York State, I believe. So Saratoga, even though it's alphanumeric, it would be considered greater than New York simply because S comes after N. So in alphabetic order, Saratoga succeeds. It follows New York. So Saratoga would be considered greater than New York. This is not a very intuitive use of the greater than sign. Typically, these operators, comparison operators that you are seeing, pick up the laser point. So these comparison operators that you're seeing typically are used with quantitative variables, equal to, not equal to, greater than, less than, and so forth. There are other comparison operators that make more sense for alphanumeric variables. Okay, but should you use the greater than or less than with alphanumeric, just remember the way to interpret the greater than, less than is alphabetic order of the values. That's the rule that's used to decide which value is greater than or less than another value. Okay. Okay, we've had enough discussion of the where clause in the abstract. Let's look at some specific examples. Hopefully that will clarify some of the discussion that we've been having for the last few minutes. So here we have a table. Remember, the where clause applies to one table, only one table. Now, the thing is that one table could be a table that actually exists physically in the database, or it could be the result of a join. But the where clause only applies to exactly one table. Okay. So here, this one table is the student table, and here's the command. It says select s dot star from student. S is the alias for student, where s dot student ID equals 789012. Okay. So this is the order in which I have written the select command, right? So remember the sequence in which the execution gets done. The first step in the sequence is that the from clause gets executed. So the software looks at this statement I've just given it, and it says, let me focus on the from clause. The from clause tells me which table to extract information from. And here it's a very simple clause. It says extract information from the table S. So here's my table S. So I'm done executing this particular step. Okay, this clause. The next clause that's executed is the where clause. And the where clause is saying, from this one table, pick out specific rows. Which rows to pick out? We want to pick out rows that meet this criteria, this condition. Okay, and this condition is, in this case, is based on an equality comparison. So we are saying where student ID S dot student ID equals to 789012. So I go through this list and I find this one row where the student ID is 789012. So at the end of the second step, after executing the where clause, my result after executing the where clause is this entire row. Okay, so I pulled out the entire row, 789012. So remember, this is very important to remember. The entire row comes out when you execute. You have pulled out the entire row based on this condition. This is the condition. It tells me which. So I pick out the row for which this condition is true. And in this case, because it's an exact match, there is only one row that meets that condition, that meets that criteria. So I pull out this entire row. So now if I think of that one row, I think it might be easier to just draw them. So here's this one row. That is the end result from the where clause. And this one row has 789012 as the student ID. All right. And in the very last step, the select gets executed. The select says pick all the columns, s dot star. So the output will consist of all these columns. So all these different columns that you have. So the output from this entire clause will be this full row. Now, if instead of saying s dot star, if I had said select s dot email address, then from this one row, only the email address would have been sliced out, and the end result would have consisted of one row and one column. Okay, so I hope you got a sense of the sequence in which these operations, these clauses are executed, and also how the where clause works. How is it executed? You pick out rows that meet certain conditions. So here's a second example of an exact match. We are saying select s dot star. So select all the columns from student S where city equals Fairfax. So it's very similar to the previous example. Here's the previous example. Here's the next one. The only difference is this time Fairfax has quotes around it. So you can see this value Fairfax has quotes around it. And the reason it has quotes around it is that Fairfax is alphanumeric. So city is alphanumeric. So alphanumeric values must have single quotes around them. Remember, we discussed this, I think, maybe in the first or second lecture where we talked about attribute domains. If the domain is alphanumeric, we typically surround them by quotes. So s.city equals to Fairfax. So the way this would work is that the system would first pick the from clause gets executed first. System knows I need to pick table S, student. The next clause to be executed is the where clause. So it goes through all the rows and picks out the rows for which city equals Fairfax. Okay, so it goes to the first row. Yes, it does meet this condition, city equals Fairfax. So it pulls out the first row. Goes to the second row, doesn't meet this condition, city is not Fairfax. So this row doesn't get into the output. Third row, city is also Fairfax. So this third row gets pulled out in the output. The fourth row doesn't. So at the end of the where clause, so after this is executed, the end result consists of all the columns but two rows. Okay, so 7, 8, 9, 0, 1, 2. Sorry, not 7, 8, 9, 0, 1, 2. Let me erase this. So the first Fairfax is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And this other one is 3, 4, 5, 6, 7, 8. So the end result after executing the where clause, we haven't yet executed the select clause, we've just executed from and where. At the end of executing these two clauses, the result looks like two rows with all columns. Last step is to execute the select clause, and the select clause says pick all the columns, so there's nothing more for me to do. If I had specified first name, last name, then I would slice out the first name and last name. Only these two columns would show up in the output, and the output would consist of two rows and two columns. Okay, so I hope you're getting a sense of the slicing and dicing that happens with the select statement and the where clause. The thing is that the horizontal slicing happens first, and then the vertical slicing. Okay, so the where clause is executed first, that does your horizontal slicing. Then the select clause is executed last, that does the vertical slicing. So moving on to more examples of criteria. So here is another criteria over here. Is not null. Is not null. Is null. These are all examples of criteria. Okay. So how does this particular criterion work? So in words, the question that I want to answer is the following: show the details of all students for whom city is not missing. So for all students whose city location I know, list their details. Okay, there's a select s dot star. Star means get all the columns. So I want all the details of the students from the table S from student, and s dot city is not null. So the way this will work, the system goes, picks student S, that particular table. The from clause is executed first. So I pick table S. The where clause is executed second. So out of all the rows, so imagine that the student table has hundreds of rows in it. So a university with 40,000 students, let's say. Okay. So it's possible that there could be international students for whom the city we don't know. We don't know the city where they come from. Okay, the origin city. Maybe that information will be filled in later. So it's possible that there are some students for whom the city is unknown, uh, where they come from. Okay, where their home bases or home addresses and so forth. Okay, so here it says where s dot city is not null. So the way that the where clause would be executed is that the system would go through row by row in the table S, and it will pick out only those rows for which the city is not null. So there is some value for city. Okay. Now instead of saying city is not null, if I had said city is null, then the system would go through and pick out only those rows where the city value is unknown, that the value for city is null. Okay. Once you do that, then the select clause is executed last. In this case, it so happens I want all the columns, so there's no vertical slicing to be done. But had I specified specific columns, let's say email address and last name, then only those two columns would have been sliced out. Okay, so is not null or is null, these are also examples of criteria that can be used for comparison purposes. Okay, an application of this not null to our vendor database is if I want to find the names of vendors for whose telephone numbers I don't know. I don't have a telephone number for those vendors, right? It's hard to contact them. So let's say I want to identify those vendors for whom I don't know the telephone number. Then I would say, select vendor dot star from vendor where vendor telephone number is null. That would pick out only those vendors for whom the telephone number is null. And then maybe I can pursue those vendors, send letters to them and say, please let me know your phone numbers and so forth. Okay. What action you take on those is different. But here for database purposes, we're just trying to explain how the select statement would work with the where clause. Okay. So far we have seen examples of one expression. Okay. So this over here, this s.city is not null. This is one expression. The result of this expression is true or false. If you go back to other examples, this guy, s.city, this expression, this is one expression and its result can be true or false. Similarly here, this is one expression whose result based on the evaluation can be true or false. So all the examples that we have seen so far involve one expression. Okay. Now the thing is that two or more expressions can be combined. So you could have expression 1, expression 2. Each of these can be true or false, and then you can combine them using some operators. And typically the operators that are used to combine expressions, since the expressions themselves could be true, false, each expression could be true or false. We combine them using and, or. This is the way in which we can combine them, and we can string more than two expressions along that way, and we'll see what the rules are for combining. Sometimes you have one expression which can be true or false, and we can put a not in front of it. Okay, and so it would give you all the rows that don't meet that particular condition. So we'll see examples of it, but the general issue that we are getting into discussing now is once we know how a single expression works, how do we create expressions that are combinations of expressions, so more complex expressions. In any case, even the combination has to evaluate at the end of the day, has to evaluate to true or false. However complex the expression, whether the expression it consists of one or is a combination, at the end of the day, the result must be true or false. Otherwise, I cannot decide whether or not to keep the row or to put it out in the output. Okay, so let's look at some examples here. So, show the details of all students whose first names are William or Bill. Okay, So select S dot star from student. So S is the alias. So S dot first name equals William. So look at this first expression. This is an expression. Why? It's got an operator in it equal to, and it can evaluate to true or false. So if I think of any row in the table, if I apply this expression, S dot first name equals William, the result is true or false. Okay. And then I have a second condition over here, S dot first name equals Bill. So if I look at either one of these expressions, this guy or this guy, either one of them could be true or false. So pick the pen again. So this guy could be true, false. This guy could be true, false. Now I'm combining them with OR. Okay, so I have two expressions combined with an OR. The end result has to be true or false also. Okay, because the way I would evaluate this particular combined expression is I'll just express it in word. I'll start with the first row, and what do I check? I check if the first name is William or if the first name is Bill. So I hope you would agree that the result of that evaluation is also true or false. Each expression by itself is true or false. The combination of the expression using OR is also true or false. And that result can tell me whether or not to include this first row in the output. Okay. So I think you can guess how the combination works. So I have two expressions. I have expression 1 and I have expression 2. So expression 1 is this fellow. Expression 2 is this fellow. Okay. So how do we combine the two? So if expression 1 is true and expression 2 is false. Oh, this is not done. Let me write over here. What is the end result? If expression 1 is true and expression 2 is false, the result of the OR, by combining the two, the end result is also true. If expression 1 is true and expression 2 is also true, the end result of OR, taking OR of the two expressions, is also true. Okay. Now, if expression 1 is false and expression 2 is also false, then the end result is false. Okay. If expression 1 is false and expression 2 is true, the end result is true. Okay, so this is the end result that would be used to decide whether or not a particular row is included in the output. So the important thing to see here is that when you, regardless of how you create more complicated expressions by combining individual expressions, the end result of evaluating however complex an expression is, the end result must always be true or false. And that's what tells you whether or not that particular row should be included in the output or not. Okay. All right, here's another example. So here also we have two expressions. First name equals Bill. Here is expression number 2. Last name equals Gates. So here, but they are combined using an AND. In the previous example, they were combined using an OR. Now they're combined using an AND. So how does that work? I think intuitively you know how that would work. You only pick the rows for which the first name is Bill and the last name is Gates. Both the conditions must be true. Okay, so each individual expression can be true or false, and the combination has to be true or false also, the end result of it. All right, so let's explore this in a little more detail. So I have expression 1, which is this expression, and I have expression 2, which is, let me see, I want to clutter this up, which is this expression. And let's see what the result would be of combining them using an AND. Okay, let me clean up this symbol over here. So if expression 1 is true and expression 2 is false, when you combine them using an AND, the end result is false. If expression 1 is true and expression 2 is also true, then the end result is true. If expression 1 is false and expression 2 is true, the end result is false. If expression 1 is false and expression 2 is false, the end result is false. So the end result is true only if both the pieces are true. Okay, so this is how the AND differs from the OR. Okay, so here also you have two expressions, but you're combining them using an AND. Important thing to see here, just like the previous one, is however complex the expression, the end result of evaluating the expression, the complete expression, must be true or false. Okay. Now, I think you can guess that these expressions can get quite a bit complex. So there are ways to make it easier to express expressions, to write expressions that could get unnecessarily complex if you just followed rigid rules. So let's take an example over here. So the query says that find out the details of all students whose first names are either Elizabeth or Liz or Betsy. As long as the first names are any one of these, I want to pull out the details of those students. Okay, so based on the way we know how to write up to now, we have only introduced AND and OR as the connectors, as the operators that you can use to connect expressions. Okay, so with that syntax, here's how we would write the command. We would say select s dot star from student as s. S is the alias for the table, where s dot first name equals Elizabeth, s dot first name equals Liz, s dot first name equals Betsy. Those are the three options that we are specifying in the query, and we are connecting these three conditions with an OR. Okay, so or one expression, two expression, three expressions connected with OR. And I think by now, knowing how the OR connection works, this expression, this complex expression, would be true as long as any one of the expressions is true. That's how the OR works. If it was an AND, then the complex expression would be true only if all the individual expressions are true. All right. Now, if you extend this to multiple options, this can get fairly long, isn't it? So an alternate way of specifying this matching, this expression is, we could say s dot first name in Elizabeth, Liz, Betsy. So we are specifying a set of values, and we are saying that as long as the first name is in that set, then we consider this expression to be true. So again, the bottom line is, regardless of how we specify it, the end result of evaluating the expression is the expression must, for any one row, if I pick any one row, okay, then when I evaluate the condition for any one row, the expression, then the end result must be true or false. Okay, so for instance, I can take the first name over here, Cosmo, and I ask, let's say I use the first option. I ask myself, is Cosmo equal to Elizabeth? No. Is Cosmo equal to Liz? No. Is Cosmo equal to Betsy? No. So each of these expressions evaluated to false. So the overall expression evaluates to false. That's how the OR operation works. Now, had I written this command, the select command, in this second alternate way, the way I would evaluate the expression is, I look at Cosmo, that's the first name of the student. Is Cosmo in this set? And it isn't. So do you see that the end result of the evaluation is again true or false? Since it's false, I don't include this row in the output. Okay. Now let's look at the use of the NOT operator. We've seen how the AND works. We've seen how the OR works in terms of combining expressions. We haven't yet seen how the NOT operator words. Okay? So here's the question in words. I want the details of all students whose first names are not Elizabeth or Liz or Betsy. Okay, so I'll pick the student as long as their names are not Elizabeth or Liz or Betsy. How would I express this in SQL? Okay, so we'll start off the same way. Select S dot star from student as S. So these two pieces we know. S is the table from which the extraction will happen, and at the end of the process, I'm saying I want all the columns of the table. Here is where things get in. This is where our focus is for this lecture. How does the where clause, how is it expressed? How is it interpreted? How is it executed? Okay. So let's parse this statement over here from the inside out. So inside it says where S dot first name in Elizabeth, Liz, Betsy. Do you see that this inner part over here, this inside part over here is exactly the same as what we had before. And what was the result that we got? The result is we got all the students whose first name is either Elizabeth, Liz, or Betsy. Okay. But now we are saying the condition, the expression that we're saying is not. We put a not in front of this. All right. So first thing to realize is that this inner expression, S dot first name in Elizabeth, Liz, Betsy, okay, is its evaluation will be true or false. So let's pick any row. Let's say I pick this first row. It's Jerry Seinfeld. That's the student. So I start from the inside. Is the first name in Elizabeth, Liz, Betsy? So the first name is Jerry. Jerry is not, the value Jerry is not in Elizabeth, Liz, Betsy. It's not in this set. Okay. So as far as this inner expression is concerned, this first row would evaluate to false. So this name, Jerry, is not in this list. Okay. So its evaluation would be false. As soon as I put a not in front of the false, it becomes true. So it becomes not false, which is true. So when I take this expression together, the result of evaluating this first row is that it's true. Hence, this first row would show up in the output. That's a long-winded way of saying that this first name Jerry is not in this set. Okay, so I hope you're seeing how the not operator works. Now I could express this in the same logic using not in. So SQL allows you to say in as well as not in, either way. So these two expressions are the same. They will give you the same result. Okay. Here is another variation of expressing criteria for extracting rows from a table. Now we'll see different variations as we go along. One of the things to keep in mind is that all these variants that we saw, equal to, not equal to, and in these the set operations that we saw a few minutes back, all these variations that you see are in your ability to create expression. These arise because of questions that are frequently posed in practice. Okay, so for instance, this operator between that you can use to create expression. Why is it even there? Because it's fairly common when doing data extraction to look for data that falls in a range of values. So here's an example. So between is a keyword, just like select from, it has a special meaning to the system. So here's an example. I have a table called player. These are athletes, I suppose. So you have a table called player, and I want a list of all the players whose body weight falls in a certain range. Okay. What would be another example from a business context? A company might want to find a list of customers whose incomes fall in a certain range. It's a fairly common type of extraction to do. All right. So we could write that expression by saying income is more than so much, income is less than so much. So we could certainly create an expression using the operators that we already know. We know operators like less than, greater than, equal to. So certainly we can create an expression using just the operators we know. But if there is a built-in operator called between, it does that work for us. We can express it much more conveniently. That same criteria, we can express it more compactly and cleanly in a way that's easy to understand. And several of these keywords that I used, you will encounter that I used to create these expressions in the where clause are there for that reason. That is, they arise fairly commonly in practice, so those built-in keywords are created. So here is how we would express it. We would say select p dot star. You know what that star means. It's all the columns from a table called player. P is the alias for the table player. Okay, where now this is one way, as I just mentioned, this is one way to express the query that we want. We want all the players whose body weight is at least 180 and at most 220. So I could say p dot body weight greater than or equal to 180 and p dot body weight less than or equal to 220. This is a very natural way of saying it. So here is one expression that would evaluate to true or false. Here's the second expression that would also evaluate to true or false, and then we combine them using AND. The end result is also true or false, depending on what you find for the two separate component expressions. So instead of saying this, instead of writing all of this, we could also say where p dot body weight between 180 and 220. So this is it's a more intuitive way of writing it. It comes more naturally, and but in terms of operations, this expression here, and this expression here are exactly the same. I mean, give you the same result. Okay, so this keyword between is commonly used to create expressions in the where clause. All right. Here is an example of an SQL retrieval query that uses between, but this time it's using dates. Okay, so show all faculty who were hired in 2019. So I want a list of all the faculty who were hired in year 2019, and so we say select f dot star. So I want all the details of the faculty, their name, the date of birth, etc. Whatever information I have on the faculty, I want the entire information. From faculty F, F is the alias for the table faculty. So where hire date, faculty hire date between 1st January 2019 and 31st December 2019. So here again, the keyword between is being used. We have a start point and an end point. Okay, dates are also numbers. Dates are also numbers. Okay, underneath even they are numbered. So we are saying that the hire date falls between these two numbers. Okay, so I could alternatively have written this as hire date is greater than or equal to 1st January 2019 and hire date less than or equal to 31st January 2019. That could also have been done, but this is a more convenient way of stating the same thing using the keyword between. Okay, so you use the keyword between as and when needed, depending on what type of query that you're trying to execute. Another example involving dates, using the keyword between. If I want to find out all the faculty who were hired in January of 2020, then I would say between where the where clause, which actually pulls out the specific rows from the table, says where faculty hire date between 1st January 2020 and 31st January 2020. Remember, these two endpoints are inclusive. They're included in the comparison. Okay. So up to now, the examples that you saw of constructing the where clause using expressions involve what we call exact matching. We would say student number equal to such and such, dates between such and such, between one date and another date. These are exact kinds of matching, okay? And they usually involve quantitative values. Okay, now, not always, but usually a lot of the time they involve quantitative values. But in any case, the type of matching that was being done was exact. So the expressions that have been evaluated, we're looking for what's called exact matching. But there are lots of searches that retrievals that one might want to do, where we have to do what is called inexact matching or pattern matching. And as you might guess, a lot of the time this occurs with strings. For instance, I might want to find all the students whose last name starts with W, things like that. So I only have partial information, and I want to select records based on the partial information that I have. That's again a fairly common type of selection, that's the extraction that's done from rows. So let's see how one would do inexact matching. What does inexact matching involve, and how does one go about doing it? Okay. So before we get into actual syntax, here are examples of 3 queries that would involve inexact or partial matching. So let's say I want to find the details of all students whose last name begins with H. So you can imagine that this is a partial match, isn't it? So let's say I want the names, I want the details of all cities whose names ends with the word city. For instance, Oklahoma City, Rapid City. So there are many cities whose names end with the word city. So I want to find the list, the details of all cities whose names end with the word city. This is a partial match, isn't it? Also, let's say I want to find all phone numbers that begin with 703 for the Virginia, one of the Virginia area code. So this is again a partial match. So a phone number has 10 digits, but I'm doing a match based on a partial matching over here, with the first 3 digits being 703. So here are examples. These are 3 examples of retrievals that are based on partial matches. So how do I express that in the where clause? So if you think of, again, you have one table, you're trying to use the where clause to pull out selected rows from the table. Okay, you're going row by row, and you're asking yourself, does the row meet the expression? Is the expression true for this particular row? Okay, now in this expression, what we're seeing here, what we're investigating, is that expression involves a partial match. Okay, so let's see how one would express that and execute, and what would be the results. So for reference, we start with an exact match. So first, find all students whose last name is Smith. All right. So the way I would write that is select S dot star from student S, where S dot last name equals Smith. So our focus here is on the where clause, the expression based on which the filtration is being done, the rows are being filtered. So we have S dot last name equals Smith, and we have quotes around Smith, since Smith is alphanumeric. This is an example of an exact match. We have seen several examples of this in the last several minutes. Okay. Now, an example of an inexact match in this context would be find all students whose last name starts with S. Okay, so you could have Smith, other name. That's lots of names that start with S. And S is a fairly common letter in terms of starting for the last name. So I want all the students whose last name starts with S. So this is an inexact match. And the keyword that is available to us to do these kinds of inexact matches is the word like. So it's almost like telling the system, please look for values that look like such and such. So I only give a partial pattern, and then I say find patterns that look like this. Okay, which means the rest of the pattern could be anything. So I give pieces of the pattern, and there are wildcards that are used to express the pattern. Okay, so the like is paired with one or more wildcards to specify a pattern. It's the specification of the pattern that is interesting, and that's what makes the matching inexact. So let's look at what those wildcards symbols might be and what they represent. Okay, so 2 wildcards that we will examine. One is a percentage character. That is a shorthand for 0 or many characters present. Okay, and then you have the underscore, which is a placeholder for one and only one character to be present. So just keep these 2 symbols in mind, and let's look at the examples of applying those. So find all students with phone number starting with 703. All right. So here we're saying that select S dot star from student. This is the clause that we want to focus on, the where clause. It says where S dot phone like 703 percentage. All right. So this is the clause. The where clause is our focus of interest in this lecture, and this is an expression. Every expression must evaluate to true or false. So how does this work? So again, let me pick up the pen over here. So let's say I have the student table, and somewhere in the student table I have the phone, and I have lots of rows. So I pick the first row, and I'm trying to decide should the first row show up in the output or not. And the expression that I'm going to evaluate is the phone number like 703 percentage. So I go to the phone number and I apply this criterion. Is the phone number like 703 percentage? So how should we interpret the percentage? What this expression is saying is, if the phone has the first three digits as 703, whatever follows, it might have 4 digits, 5 digits, 6 digits following. It could, it doesn't matter. As long as the first three digits are 703, then we say that this expression is true. So if the first student's phone number is 703-993-4256, it would be a match. However, if the first three digits were, let's say, 212, and then you have some other number, then it's false. So the phone number is not like 703%. So this symbol, this wildcard percentage, is a shorthand for multiple symbols that might follow after it. Okay, so 0 or more characters following 703. That's what this shorthand represents. So this expression that you're seeing is, as long as the first three digits are 703, this expression will evaluate to true. Okay. Let's take the second example. Find all students having a phone number with 993, with digits 993 together. That means in the phone number, anywhere in the phone number, 993 should appear. These three digits in that order should appear anywhere in the phone number. So just try and think of the difference between here, this expression, the use of this wildcard here, and the use of this wildcard here. So the question says the phone number should have 993 anywhere in the phone number. So what does that mean physically? It means 993 could be preceded by anything, 993 could be succeeded by anything. As long as there is 993 in the number anywhere, then this expression evaluates to true. So we have percentage signs on either side of 993. What's the interpretation of that? Remember, percentage is a shorthand for any number of symbols, any number of digits. So 0 or more. So by putting a percentage in front of 993, we are saying 0 or more digits could precede 993. By putting a percentage after 993, we are saying that 0 or more digits could succeed 993. So this percentage, 993 percentage, is simply an SQL way of saying that the digits 993 appeared anywhere in the phone number. Okay. Then wildcards, we are familiar with wildcards when we do file searches on our machine. We are fairly familiar with wildcards. But you're seeing the use of wildcards in SQL. The use is similar. It's for inexact matching. Okay. Now let's look at this third example here. The wildcard symbol that we are using is underscore rather than percentage. Okay. So let's look at the narrative version of the question. It says find all students having phone numbers with digits 993, but they shouldn't appear anywhere in the phone number. They should appear after the first three numbers. So after I don't care what the first three numbers are, but following those first three numbers, I want to see the digits 993. Okay. So how do I say that? In the expressions, I would say where s.phone number is like, again I have to put quotes because this is an alphanumeric string. I have the 993 over here, but I precede it by 3 dashes. Now this looks like one long dash, but there are three, it looks like one long underscore, but there are really 3 underscores here. So underscore, underscore, underscore. Those are the first 3. So every underscore is a placeholder for one digit. So I put 3 underscores here, 993 followed by percentage. So I'm saying that 0 or more digits could succeed 993. I don't care about those. But 993 must appear after the first 3 symbols. All right. So try and in your mind sort out the difference between this expression here and this expression over here. What's the difference in the results that will be produced as by evaluating those conditions? In any case, whether the expression is this or the expression is this, any expression must evaluate to true or false when it comes to executing the where clause. So you're saying where, pick out the rows where this is true. Pick out the rows where this is true. So think of the where as the outcome of the where is true, false, and that will tell you which rows to pick out from the table. So you're doing horizontal slicing using the where clause. Okay. All right, in summary, what are the topics that we have learned in this lecture? We have focused on the where clause. In the previous lecture, we had focused on the select from clause in the select statement. Here we have selected on the where clause, and the conceptual thing to remember is the where clause allows you to slice a table horizontally. It slices out certain rows. In order to slice out certain rows, you have to specify the condition based on which the rows should be sliced out. So whatever follows the where clause is an expression. The expression must evaluate to true or false for every row when it's evaluated. Okay? The thing is that this expression can get fairly complex. It can be composed with many smaller pieces together. So you have simple expressions, then you can combine simple expressions using logical operators like and, not, and or. then there are reserved words like between and like that make it easier to express the condition. And you have keyword for doing partial matches, wildcard searches. So there are more options that are available. Again, it depends to some extent on the software system that you're using. But the basic idea is very simple. Somehow in the where clause, I need to be able to write down an expression, a logical expression that evaluates to true or false for every row in the table. If it evaluates to true, I put the row in the output. If it evaluates to false, I don't put the row in the output. The complexity is that this condition which evaluates to true or false, that can be simple, it can be fairly complicated, depending on what are the criteria that are to be used to filter out the records that you need. Okay.